for the level of cooperation and engagement. Your inputs have been very valuable. It has enriched the quality of the deliverables under this assignment. As we assemble today, we are in the concluding phases of the consultancy assignment. We look forward to a very productive engagement. We look forward to your continuous input, technical support, and collaboration towards enhancing the quality of our transmission and distribution network. Over the long term, that will reduce our cost, our operating costs, our cost of procurement. It will enhance safety. It will allow us to consolidate all our materials and equipment under a single framework, and it will strengthen our sector, make our sector more robust and resilient to the ever-changing energy market and energy environment. Again, I want to say thank you for the opportunity of your time, and we look forward to very productive and engaging discussions today. Thank you so much, and welcome again.
The Shubayo is the Executive Engineering Major Commission.
Thank you so much. It's a very productive and interactive discussion. So we'd like to call anyone from Mines and Energy, MME. Is there any representative from MME? Okay, so we move to RREA. Do we have a representative from RREA? Okay, can you please come and give your remark? Thank you so much.
So maybe just joining us. This is the official Facebook page of the Liberia Legislative Corporation, and today is the LEC T&D Standard Optimization and Ferry 100 Project Fund Workshop. We have been held here at the Better Casa Hotel. So a representative from the RREA is about to make a remark.
Good morning to So I'm here representing the Rural and Renewable Energy Agency. It's an honor to be part of this meeting, and it is our hope from our Executive Director Samuel Nangwe that we will achieve the purpose of this meeting, and we look forward to a fruitful meeting. Thank you.
Thank you so much. Let's move to the next remark. ERC.
Representative from the ERC is here.
Good morning. I bring you greetings from the MD of the LERC. He could have loved being here this morning, but he has other meeting to attend to. So that's why he sent me to represent him. One key thing he told me before coming here is the Commission is interested in having a uniform standard across the electricity sector in Liberia. Based on his experience, he noticed that everywhere in the sector you see different materials, you see different installations with mission 300, and with the clear goal to have a standardized standard for LEC. He feels that that's a breakthrough for the electricity sector in Liberia. So he's willing and open to work with LEC, the donor organization, ERICA, and all other persons in support of this mission and project. Thank you.
you so much, our representative from LERC. The next remark will come from a representative from RFCC.
Thank you, everybody, for the warm Monrovia welcome this week. So I'm Andrew Yavinsky from RF Catalytic Capital and the Mission 300 Accelerator team. I want to provide a quick thank you to the LEC team for being such gracious hosts to us, the NRECA team for being great partners on this project, our Mission 300 partners, the MME team, the LERC team, the RREA colleagues, and other stakeholders that are here today. So Mission 300, I think as a lot of you know, is the World Bank and African Development Bank's initiative to bring 300 million Africans energy access by 2030. A few of the key pillars of Mission 300 are strengthening utilities and having strong utilities, and having strong T&D infrastructure. And I think that that's why a lot of us are in the room here today for those two pillars, which are also built into Liberia's National Energy Compact, which was signed at the Dar es Salaam Mission 300 Summit last year in January. And Liberia's National Energy Compact sets some bold, I think, but also practical goals for the country. Ramping up to 100,000 new households connected per year, reaching at least 75% national electrification rates, and adding significant generation capacity, attracting investment, and so on. I don't think that that happens without the folks that are here in this room today. So I'm happy to be here. I'm looking forward to meeting with all of you throughout the week. And yeah, I'm looking forward to a great workshop. So thank you for everybody that's here in this room to kind of bring a sector-wide engagement to this project and workshop. So thank you.
Warm welcome to everyone. My name is Nicholas Allen with NRECA International. Thank you to LEC again for the collaboration and leadership on this project. Warm welcome to everyone from LEC. Thank you to RREA for their participation today, LERC as well for their words and guidance, LRA, and of course the ministry as well. And a big welcome to RFCC colleagues, the Alliance colleagues, World Bank, African Development Bank. Thank you very much for being here today. As it states on the slide, this is our final workshop. This has been about a 10-month project so far. It'll be probably a 11 to 12-month project in the end. A lot of work has gone into this from pretty much everyone in this room, I believe, at some level. So again, a big round of applause to all of you for all the effort, collaboration, inputs, advice. Hopefully this presentation will provide you with a summary of all the work completed so far, give you a well-rounded background on what the goals of the project are and what we've accomplished. Thursday's session will cover the final task, which is the distribution planning and design manual. So with that, let me just briefly introduce our team again. Luis Arizmendi has been our lead in terms of stakeholder engagement and also on the distribution side. Aaron Menin, as you all know, distribution side has done a lot of effort on that part. Pablo Franco on transmission, and Andres Perez as well, working on our transmission side. We'll each be presenting today to you several sections of this report, of the various reports and the project. So without further ado, let me, how do I advance the slides?
There is
All right. Thank you. Great. Well, here's our content for today. We're going to take you through each of the 8 tasks of the project. As you know, each one builds more or less on itself in terms of the review of the T&D standards that exist, the review of the technical specifications in those sectors, and then coming up with recommendations for those, and concluding with the distribution planning and design manual. And our afternoon session will focus heavily on the implementation plan. Hopefully you've had a chance to review that literature report, but we'll be providing that to you, and we'll have some sessions to help elaborate and further define that with all of you. And I'll go over these again in a minute here. But before doing so, let's provide some context on why we're here today, and specifically looking at standards and specifications. Why is it important that we gather this project together and gather you all together to review them over the last 10 to 11 months? So as you see here, we're presenting kind of a timeline of, particularly if you look in the middle here, these are the major projects in the distribution and transmission sector in Liberia, and you can see that there have been a number of them that have lasted many years. But we also know the different donors that are involved. And with each donor effort has come a new application of different standards, sometimes aligned, sometimes not, through different consultants, different country contexts, etc. And then you also see the markers that display the establishment of LERC back in 2015, and then its operationalization in 2020. And then now we have LSA coming in as an authority on standards in Liberia, and that's just recently, 2022. So you can see that there's been a pattern of standards being applied from different contexts, but never harmonization of those across the sector. And particularly never harmonization with LEC and its partners as the main vehicles for that. Often it's been driven by consultant teams such as ourselves. So our goal really today through this project was to carry this forward into the unified recommendations for T&D standards. A little bit of background, as you know, RFCAT, the Capital and World Bank and the African Development Bank, as Andrew mentioned, have formed the Mission 300. And so this is the goal of connecting over 300 million people in Africa by 2030. And Liberia's compact plays a key role in that, obviously, and that's under development. And I think you'll be hearing a lot about that in the coming days and months. This project is part of that development of the compact, I believe, and aiding to laying a foundation for the acceleration of the M300 mission in Liberia by optimizing the transmission and distribution standards in the network of LEC. A brief background on NREC International. As you know, we've been involved in Liberia for quite some time, initially through the Beyond the Grid program, sponsored by the USAID. Worked heavily in the development of an electric cooperative in Totota, and I'm sure you've heard about that through different team members. We also worked alongside LEC in the construction oversight of the Ganta-Banga line back in 2019. We've also worked on the Liberia National Electrification Analysis with the World Bank and the Ministry back in 2020 and 2021, and an update of that in 2024. And most recently on the KAIHA 2 mini-grid project with RREA, designing both the mini-grid side as well as the distribution system for that system. So our involvement has been deep and consistent in Liberia. We're very happy to be working alongside all of you on the development of the electrification sector here. NREC International was formed in 1962. We are part of the National Electric Cooperative Association in the US, and our mission is to continue to empower communities and empower communities to improve their quality of life. So again, maybe just to quickly review the project objectives. This was to review and redefine the transmission and distribution design standards and specifications across the different voltage levels operated by LEC in Monrovia and its network. The key goals were to look at optimizing cost, so improving the cost effectiveness of the network, most importantly, improving reliability, so through standardization, enhancing the reliability of electricity supply. I think in this case we should probably say distribution supply. Harmonization, so harmonizing the standards across the network and its various contractors, and of course leading to the ultimate goal of allowing for accelerated expansion and connections. We're going to go through each of these tasks in detail, so I'm just going to briefly touch on them as we'll present all the specifics about the analysis in the next slides. But the project did cover 8 tasks in total. The initial task was the startup of the project, initialization of the work plan, and particularly stakeholder engagement. So understanding who in the sector was involved in distribution and transmission planning and design, and who used standards for those, so that we could gather their comments and incorporate them into the project as we went along. Tasks 2 and 3 involve reviewing both the transmission distribution network, but also reviewing the regulatory framework and standards that existed. And task 4, review the material specifications for the T&D systems. We then move on to the latter half, the second half of this project, which was the recommendations and development of the distribution planning and design manual. So tasks 5 and 6 specifically addressed the review and recommendations, and then task 7 concluded with recommendations of equipment and material equipment specifications, leading to the final task, which we'll be presenting on Thursday, which is the creation of the distribution planning and design manual. So with that, I'm going to hand over to my colleague Luis to take you right into task 2.
Thank you, Nick, and good morning to everyone. My name is Luis Arismendi, and as Nick said, we have been involved a long time here in Liberia, and I'm very happy to be working with LEC. So let me start with the task number 2, which was the assessment of the existing network. For that, let me talk about the purpose, assess planning and design practices, to evaluate the grid configuration to see how the distribution of substations, high voltage lines, medium voltage lines, feeders, low voltage, that was part of the analysis. We evaluated the network reliability. We'll talk about SAID and SAIFI indexes, and prepare the technical loss analysis for LEC. That's what we did. So how was this conducted? We had surveyors moving around the whole network with some equipment, some iPads, to get all the information of every single element of the network. In this particular case, it was poles, transformers, and all the equipment. Basically, in collaboration with LEC, because we had a quality check-in together with LEC, we basically went all through the network to have all the information for this analysis. We recorded the attributes, characteristics, conductor details, power geometries, transformers, capacity, and as I said, every data that was necessary to analyze the network. And as a result, as you know, you have 13 substations, high voltage substations, and also we included the collaboration, the CLSG substation interaction with Mount. With this survey, one important thing to highlight is that we found a discrepancy between the number of feeders, the 8 kilometers of feeders, and so there was a validation that LEC is in big need of updating. Every time a new construction is done, there is a need to incorporate those changes into the system, into the database. That's an important outcome of this activity. As you see, there were 945 kilometers reported in the LEC database, but we found more, 1,072 kilometers. And the number of transformers, there was also a difference. It was reported 3,300 plus, and then we found a little bit less. What could be the explanation for this difference or discrepancies between the numbers? One thing we observed is that from the original database, you see here, you have several transformers, and this is the real situation found in the network. So when we had this discussion with LEC, what happened here? So the explanation was that there is a tendency to increase the capacity of transformers, to retire, let's say, smaller transformers, put larger transformers, and to increase the length of the low voltage. This has implications in technical losses, in voltage drop, that we were also discussing with LEC, and is part of these the recommendations we will give later. This is a big infographic of the LEC's infrastructure, 13 substations, and as you can see, we have incorporated this. This was my partner Pablo will speak about the modeling. All this infrastructure was modeled in a software in order to conduct low flow analysis and all things. We will talk about this later. Part of this assessment, what were the conclusions of this assessment? So there is no harmonization. You can find in the high voltage network, you can find tubular poles in certain sections combined with lattice towers, even in the same high voltage feeder, which is something that precisely is what this project is for. The idea is in the future when you build new projects, they will have a uniformized standard to do the construction. For in the terms of tower design, most transmission lines use double circuit towers. That's what we found, but only with one circuit strong, allowing for future expansion to incorporate a new transmission feeder. What is the risk? Mismatches pairs, inconsistent electrical mechanical performance, inefficient maintenance based on the difference between the different towers or structures. Conductor types, what was found is LEC is using basically mostly AAAC conductors, aluminum conductors. The standard cross section 150 square millimeters, but in sometimes you can find 240 square millimeters to increase the bones between certain substations. In terms of insulators, also differences. In some areas, you have porcelain, in others, polymeric type of insulators, glass insulators. This needs uniformization, so say, because it has a lot of impact in the procurement of equipment, in spare parts, in replacement, in performance of the high voltage network, in the sense that characteristics of the insulators are different. So you have sections of the high voltage network that are more exposed to arcing or atmospheric influence because of those differences. One thing which is important to highlight, vegetation management is really required. We also observed that many lines were with wind counter, many of them with encroached branches, trees. And this is a matter of concern because it impacts reliability, and this is something, of course, that needs to be avoided to comply with the regulations. Around the airports, another issue is, according to the aviation regulations, the towers should have like a standard painting and with alternating bands, orange, to avoid some birds or even aviation. The lines should be fully visible, and this is not followed. Very safe marking devices. As environmental concern grows, you have path for birds, for migration, such as birds, and the lines need to be marked to avoid birds colliding with the high voltage lines. Foundations in some locations were found slightly tilted. So again, a matter of concern for reliability. research highly dangerous practices. Some people put clothes and on the transmission lines using the towers to hang things or to put some ropes. And this is also.
Oh. Let's wait a little bit. Yeah. Let's wait a little bit so it's
So taking a quick technical break, to be right back to continue the live broadcast. Taking a quick technical break.
Logic when in the transmission recommendations we will discuss more about these protection schemes. Standardized CPs and BTs across the system and implementation of an IEC standard which should guide the standardizations of single line diagrams and equipment specifications. And to finish my presentation is just a positive message in terms of the reliability that has been achieved by LEC in the recent years. As you can see, the duration of faults has reduced dramatically in the last 3 years from 654 to 49 hours per customer, which is 92% reduction, which is something for LEC to be proud of. And similarly, for the frequency, the number of faults per customer, it also has reduced dramatically, 86% reduction. And of course, it doesn't mean that LEC needs to relax. It's a continuous process of improving every time more and more the standards for the quality of service for the customers. So this is my final presentation right now. I will pass to my colleague Pablo. Thank you. Sorry, any question about the assessment of LEC network before we continue? Okay, thank you.
Thank you, Luis. Good morning, everyone. My name is Pablo Franco. I'm a transmission expert for NIRCA. So we continue the presentation with the findings we got on the transmission network. In principle, we use professional software for modeling the network. We introduced all the substations and main elements, the lines, transmission lines, and got at the starting point the power consumption during different seasons, and the rainy season and dry season. As we can see here, the current scenario, the current year, last year, and the projection for 2030, with aiming the goals for the M300 project. So the criteria we used, considering the feedback from LEC, was doubling the consumption. So as we see from 2025 to 2030, we have double in all the power. Okay? At the same time, we introduced as well a different projection of generation during these 5 years. As the result of the analysis, we got, for example, for the 2025 rainy season, that the network behaves quite well. So no overload, except Painesville's transformer that is close to the 80% of the rating capacity. So it's like an alarm sign to be considered. But when we go to dry season, this transformer already reached 100%. That means it starts overheating and reducing drastically its life cycle. So it's something to be considered in order to improve and enhance the capacity, for example, double the transformer, or for managing the increase of the capacity of managing the load. When we go to 2030, with the increase in the consumption in the load, we are alarmed because several substations, the one in red highlighted there, they reach unacceptable overheating or overload, reaching 350%, I mean 3 times the capacity of the transformers. Combo Town, similarly, 160%. Stockton Creek, Bush Rock, the transmission line as well is not able to carry out the capacity to transport the energy. So this is a very crucial. We are now 2026, so in four years, if the assumptions are maintained, we will get a very unstable network, not able to fulfill the needs of the population. So current configuration is not working, is not prepared to carry out the incoming situation. During the dry season, we have similar, a little bit less critical, but still worrying situation, considering overloading of all the transformers in several substations, and even voltage issues. The voltage has dropped below the acceptable limit, the 5%, in several buses in substations. So obviously the conclusion is that the network should be upgraded and enhance the capacity. So this was the current scenario and the projection under normal conditions. Now, we analyzed using the professional software Power Factory what happened, what's the behavior of the network under several faults. One fault only at a time. It means one line out of service, one transformer out of service, one fault, maybe a short circuit between 2 phases of a line, etc. So in that case, for 2025 rainy season, we have again Painesville station, substation, with the behavior showing not lack of capacity to handle the situation. So, nevertheless, Bush Road, if we see in the dry season, we have Bush Road substation also overloaded. But in the rainy season, given that the non-profit substation will be generating, Bush Road is not overloaded this time. Now, the same situation in the projected scenario for 2030 give us again several substations. We see they are almost the same. So we are locating where the problem is and where the upgrading or enhancing capacity should be directed to. So we have again Painesville substation overloaded, transformer, and the rest of substation showing similar situation. Now, when we go to dry season, the situation is slightly better, but even overloaded all the transformer. So, situation in that scenario is that every single fault will conduct to several customers to be without service. I think the message is quite clear regarding the actions to be taken. Okay, regarding the analysis we did for the loss in the network, we have differentiated 2 sections from the generation till distribution substation, and our calculation showed around 1% losses during the dry season and a little bit higher for the projection 2030, but still within acceptable limits. Now, in the distribution side, from the transformers distribution substation till the end customer, including the medium voltage line, the low voltage lines, and the service drops, we have 3.85% of losses, which still is within the acceptable margins for an utility, a vertical integrated utility like LEC. within the margins acceptable even in the utilities of the region. Now, it goes to a very, very interesting and maybe subject to discussion issue regarding the non-commercial issues. Losses. We have, from 2021 to 2025, the number of customers has doubled, or more than doubled. And the sales, we have the information only for 2025, no possibility to compare. But what we see is that the aggregated losses for 2025 is around 45%, according to the information we had access. If we subtract the technical losses we were just seeing here, 3.8 and 1% around, we get non-technical losses of 41%. It is something very worrying and need to be carefully analyzed to see the reasons and the actions to be taken to improve. That's why we come to the recommendations to try to reduce these technical losses. One of our main recommendations, I think everything is in line with this, is the deployment of the smart system meters. Using the standards we recommend, using the advanced meter infrastructure with avoiding the possibility of tapping the meters, guaranteeing accurate measurement and reading tele-reading. In such a way, the theft that currently are present in the meters can be avoided or at least reduced. Also, the billing system and enforcement of the collection should be increased. And finally, conduct some capacity building of the teams who are in charge of these previous measures. So at the end of the day, we consider that these measures will be of great help to reduce the commercial losses. Okay, above that, as Luis was saying before, one of the issues could be impacting this scenario is the lack of standardization of the equipment. We need to systematically, as part of the supervision of the network, to detect the hotspots. For example, when we have a loose connection or we have the vegetation interfering with the supply, it could be a good opportunity to improve. Apart from that, we have seen, and everything is aware of that, several misuse of the installations. The population sometimes use the existing infrastructure for personal uses, like hanging clothes, introducing as well a very, very risky practice that need to be avoided, and population need to be educated under these conditions. Well, so far this part, I think my point has been exposed. If you have any question before continuing.
There's one question. Okay, so it's question and answer time after the few-minute presentation. Let's get across the floor. Okay.
So I was just looking at the recommendations, and I did not see anything that has to do with increased manpower and logistical support. These two are very important in terms of reducing response time. As we know, many cases are reported daily, but the inability to respond in time also is creating theft. So that's something that we need to look at, increase manpower and logistical support. Thank you.
My name is Iwan Masaba, I come from TrueLiberia. Regarding the recommendation, I could suggest that you put in where private companies will be able to take some of the areas from LEC so that you can be able to reduce that technical and commercial losses is very high. And trust me, you can have the highest manpower, but once it is not, it is solely on the national utility, that is LEC. You always see these things. Take from me, there are some of you guys, as soon as the power team leaves the field, they go back and then we're connected. And if it is a private company, I don't think such a thing will be done because the mayor, he wants to raise his money. Yes, so please, I would suggest that you add that to the recommendation. Thank you.
Okay, thank you very much.
Senior Manager Samuel Guido is also here. This is of the crew, rest of the crew from the department house.
Executive from the Ministry of Mines and Energy. My question is to the previous speaker with regards to the issue mentioning grid reliability, and that I was concerned. He spoke about lack. I just copied a few because it was fast. And I tried to look at the recommendation component to ask a question. And I'm speaking basically from the policy perspective at the Ministry of Mines and Energy. So I was looking at the key challenges currently that is limiting the transition from the conventional to digital relay systems in Liberia. That he did not mention the key challenges. Then I want us to take into consideration also the Ministry of Mines and Energy and the LEC, meaning that the energy stakeholders, what budget prioritization for grid modernization that could be recommended, looking at the competitive demand of electricity currently in our country. Thank you. Okay, thank you. From the Ministry of Mines and Energy and the previous one. Yeah, let me talk about this. We will discuss that this afternoon. We will have an opportunity to incorporate all this feedback from everyone. In terms of the ministry, as you said, establishing the policies and the oversight of the entire energy sector. This is really something that when we incorporate all the collaboration discussions and feedback from all of you this afternoon, please stay this afternoon in the focus groups. We didn't want to, go through the entire this afternoon. Be part of one of the groups and incorporate this feedback. And we will have this afternoon plenty time to discuss this particular issue, okay? If you don't mind. Any other concern that you have, gentlemen? Anything that you would like to? Okay. Okay, the next task of this assignment was to identify the regulatory framework affecting the energy sector in Liberia, and we had different meetings with all the stakeholders, and we made an evaluation of, and we also provided some recommendations in that. For the LERC, LERC is advocating for harmonization, and they identify that there is a need of regulatory enforcement. LERC has been working towards designing like guidelines for inspection, and many inspections have been done, but in the conversations we had, they said, okay, we need to enforce the regulatory compliance with that. And so they have been doing some of the inspections, some of the job, but still more needs to be done, and also enforcement of those recommendations from LERC. One point that is coming, and it's becoming more and more usual in the discussions, is net metering. The networks are becoming more active. So before it was passive, but customers are incorporating more solar power, more batteries into the system, and this impacts the grid. And currently there are no regulations about it. And for the design, for the penalties that will be imposed to a mini grid, let's say, that connects to the network and causes fluctuations and causes problems. And LERC also was suggesting that instead of using SID and SIFI, incorporate, basically because of data, what they were proposing is calculating these indicators not based on customers, but based on capacity installed. And this is ACD and ACID. LSA was in favor of adopting IEC standards. They have been elevated just recently, 2-3 years ago, to an authority, and of course they have limited resources and capacity to let's say, inspect and enforce also regulations, or even evaluate standards to check their applicability in Liberia, because of basically resource constraint. And they would like to make a compliance shift from pre-construction inspection procedures to be developed, rather than going after the infrastructure is built. For RREA, what was discussed, technical challenges in rural electrification, line routing, transformer sizing, and line clearances. That was the main concern for RREA. Design inefficiencies, large capacity transformers with extended low voltage networks, which, as I said before, impacts the voltage quality for the customers, especially in rural areas where you have, more extended low voltage lines. And they also exposed vulnerability. They were proposing different kind of poles in certain areas because they are subject to fire risk. The Ministry of Mines and Energy has been working in an electrification master plan. Perhaps, we will know more about it this afternoon, will be discussed, and advocated for implementation of these standards nationwide. And the ministry is also very much involved in new solar generation going to cover basically part of what we discussed or what Pablo exposed. that lack of generation will be an issue. Regarding EPA, we found that it's properly applied, all the regulations. I think this institution is very well prepared, has been imposing the adoption of ESIA studies for every single infrastructure that is built. This is pretty much your hierarchy of regulatory instruments for Liberia: electricity law, then the license regulations issued by LEC, electricity tariff regulations and methodology, then comes the customer service and quality of supply regulations, which basically talk about voltage, frequency, and operating license of the connected entity. Whatever service provider applies for certain area of the nation needs to follow the operating license. The LEC, the grid code, which governs planning, connection, operation, and which is basically mostly the application of our work here. And M300 was pretty much focused on the grid code. Finally, any codes, regulation, procedure for West Africa Power, which was the gap analysis for LEC, let's say. We discussed already that the standards landscape is fragmented, many different standards, European, South African, American. One thing is LEC is planning to submit some medium-term expansion plans to LERC. LERC should be, regulating and overseeing what is happening in terms of expansion in the network, and it's a breach of electricity code, and it was agreed, it was discussed with LEC that this needs to be done, this medium-term expansion plans presented to LERC. The Standards Authority requires substantial financial support to be able to conduct these studies that are required. Currently, they are working only under by demand. LERC has a solid legal foundation. We have seen huge evolution of LERC. When you go to the web page, you can find all kinds of regulatory instruments presented very nicely, very comprehensive, and this is a good issue for Liberia energy sector. There are not still long-term network development plans developed by LERC in some other countries. When you compare, you do some benchmarking, you will find that LERC in other countries, the regulatory body normally has a long-term expansion plans or development plans. Technical codes need expansion to address system restoration, cyber security. This is the future. Dynamic grid control, net metering. So there is a lot of items to discuss and to incorporate into the regulations. There was also a discussion about cost-benefit methodology used to evaluate all the projects. Projects have been evaluated with different methodologies, every one of them, and one uniform methodology could be applied and enforced by LERC. And finally, for LERC, the website should maintain a public-facing platform for sharing real-time or historical grid data. Regarding EPA, all the projects undergo an environmental and social impact assessment, from the very small to the very large, which is extremely important to preserve environment in the projects. Other gaps, I think we already discussed that. Non-systematic aviation safety, flight diverters or line markers, vegetation management, and public safety. This is basically, the regulatory framework, also compliance that it needs to be enforced. We also discussed this whole material risk. In some areas, farmers produce on fires to optimize the crops and to clear vegetation from the land, to cultivate some trees, palms, or whatever. And when they do that, they impact the poles. So what we were thinking to recommend is in certain areas where this risk is evident, we could incorporate concrete poles that will last longer. And they need to properly dispose the poles, the wooden poles that have been treated with creosote. Again, this is a treatment to avoid termites and insects, but it also causes impact in the environment, so it needs to be considered proper disposal of those poles as they get older and older. Okay, I finished this regulatory framework analysis with main stakeholders here. So if you have any questions before I pass to my colleague. Let me pass to Andres.
Yeah, excuse me.
Sorry.
Can you go back a little bit to
Yeah,
the
absolutely.
regulatory instruments you mentioned? Okay, where you have the regulatory instruments, where you talk about the electricity law.
This one.
Yeah.
Okay.
Okay, here, there's a little issue that I got here. The electricity law came into the 2015. It's the 2015 electricity law. What guided the electricity sector before this law is the National Energy Policy that came into being 2009. So I think that instrument should also be mentioned in this document. Thank you.
Very good. Yeah, please.
So National Electricity Plan 20...
National
Energy Policy, sorry. National Energy Policy 2029 and the Electricity Law 2015. Very good. Thank you. All right. If there are no more questions, let's continue with the presentation.
Thank you. Hello, this is Andres, and I continue with the task number 4. That is purpose for review of existing specification and mainly analyze ability and suitability for local conditions. So, as we already talked, LEC infrastructure is mainly fragmented by different donors. This is an example of different towers from different donors, like a lattice tower and TrueLiberia tower. We found that. So this also is found and impact on reliability in terms of as we talked on logistic and replacement materials and spare parts. So in terms of maintenance, when we ask for information from LEC how is doing the maintenance for the entire grid transmission distribution, we found that mainly all the corrective actions, no preventive maintenance, it was found. So we found that they really increase the safety and safety numbers, and it is a bad situation. So the recommendation here was to shifting from a reactive maintenance going to a preventive maintenance, and that will highly reduce the cost of the maintenance itself. that was the maintenance benchmark that we found in the LEC network. LEC is doing in intervals between 2 to 7 years or even for months depending on the equipment. Here there is a table explaining how they do the maintenance for switch gears or transformer. And we recommend shifting from timing maintenance, going for another system, going for the state of the equipment instead of winning the time. So the recommendation we made in this report was at least doing more frequently and also doing in terms of the equipment. That's to say, if equipment is already installed or is in a good condition, you don't need to go monthly or every 2 years. Let's go for a condition system instead of a time system. Also, we recommend in this preventive maintenance program, every time an active line, a substation, a distribution line, a distribution transformer is inspected, it has to be any data that is captured has to be stored. So this is a photo done by a drone, for example, and we see some roasting in the bolts. So this kind of photos, and when it's doing the inspection, it has to be stored by LEC. Also, we recommend to start working in distance anomalies. We call that for vegetation maintenance or distance against houses and other buildings that is not fulfilling all the electricity code and electricity distances. So we recommend to make a catalog labeling all these different anomalies and these different pictures in different codes that helps all the inspector to identify what is good and what is wrong in the grid, and also to in the future to automatize this kind of inspection. We see here different anomalies, like foundation of a light tower almost collapsed. We see also some rusting, and we can suggest here to classify between grades. Grade 2, grade 1, grade 1, grade 2, just to get this information for the inspector, for the maintenance inspector. This is another example how insulator is damaged. And this is the suggestion and the recommendation we make for qualification of these anomalies. During our survey for the whole entire LEC grid, we detected some violation in some bad practical use for the equipment. We saw some bypass on fuse lockouts that is very dangerous. We see we are already seeing some poor earthing arrangement and also joints that are misused, or also some transformer that they are liquid with some oil there, and also we see during the inspection of the grid there is a lot of let's say there's not much physical protection against the transformer or some other high voltage equipment that is going to be critical if somebody touches or it's going to be there. We already talked about the insulator inconsistencies and the fragmented donors, so we recommend going for polymeric, like the standard for LEC. We already talked about that. And for splicing, we should avoid irregularities in joining practices. So this is one of our main observations, and we recommend in the following slides. So, in terms of maintenance and in terms of to collect all data and all information that the LEC is requiring in the system, we suggest and recommend them to go for a ERP software that they can centralize all the data, they can centralize all the images, all the outage data, all the every data is in the company, it should be there and in one place, and it should be in the cloud, that's in one place. that will allow all LEC departments to work together instead of going the same documentation and the same data in different departments. That is going to be a lot of work. So this is one of our main recommendations. Also, we recommend start doing preventive maintenance, doing some analysis with some person from whatever as usually a hot point that is signal something is going to fail in a short time. So this kind of tools are not really expensive. They can predict and they can prevent you from outages or for future issues. Also for distance measure for distant anomalies, there is some sensors like here are using more mature companies are using that for measuring distance. So as far as we know, LEC is doing a new pilot program for preventive maintenance, and they are doing in a cloud-based with maps, and the code is SR123. So we are very happy to know that this information, and we highly recommend them to keep improving and to keep allocating some resources there for the maintenance program. So this is the end of podcast number 4. So if you have any question, please bring it up. Thank you.
Thank you, Andres, for the continuity of the presentation. Now we are moving, no more questions. We are moving to task 5, in which we have evaluated all the existing standards which are in use by LEC and how they may be impacting the reliability of the grid and the performance. So we have analyzed each and every existing standard, and how are they linked to the commercial and non-commercial, well, basically to the technical losses. We have also evaluated the operational cost and how are they conditioned by the current standards in force. Also the environmental and safety compliance and how it can be improved regarding the customer connection and quality of service, define the environmental and safety risk existing in the network in the current state. Finally, we do some recommendations for improving the existing scenario. So we already discussed this statistics previously regarding the key performance indicator, SAIDI and SAFE, which stands for average interruption duration index and average interruption frequency index. That means how the current outages impact the customer experience in terms of duration of each interruption and the frequency. We have seen that the improve is quite impressive, but there is room for make it better. If we, for example, analyze the existing operational cost and the trends we have observed during the last years, increase the environmental and safety aspects, and finally we will offer as well recommendations for a further improvement in this field. We saw before the technical losses and the non-technical losses. It's just a summary of the previous discussed task, and as well as the measures to be improved. One of the main important things is to strengthen the SCADA scenario in which we can interconnect all the substations and have a fully connected network which guarantee a higher reliability of the service. We, during our visit to Mount Coffee substation, we saw that there are some relays, multifunctional relays, but they are not configured to operate for the functions they are designed for. So this is a good opportunity again to improve and to start interconnecting the substation to produce or to obtain a full network interconnected. At the same time, if we harmonize the maintenance using a status-guided approach instead of reactive status, I mean, the maintenance should not wait for the asset to be in bad condition to intervene. It should be maintained periodically. And finally, the approach regarding the metering, to have more resources for LEC to be able to invest in the improvement of the network. And this is directly related to the metering and collection policy. Well, regarding institutional regulations, we found that LERC and EPA works collaborating for approving the permits for the projects, but there is always room for improvement as well. For small projects, the delay is quite short, 15 to 30 days, and for large projects, the approval for the environmental social impact assessment is around 90 days. It's 3 months. It could be reduced. It could have a good impact in the benefit of the project. Normally, the main reasons why this delay is so long is related with the documentations and fee payments. The deficient reports with missing information or inaccurate information, and the community resistance linked to maybe to the late engagement with the local communities. So those facts have been identified, and they are easy to improve without a significant investment. So it's something doable. That's why we recommend to improve all these previously mentioned limitations. Now here we did an exercise with numbers. I mean, the information we had was not complete, but give us an idea of how the management has been giving us the results of the SAIDI and SAFE indexes. So previously we had 2 years, 2023 to 2024. 24 is in orange because the information was not complete, so we extrapolated the data, just obtain the expected income for the year. We see expenses from one year to another has almost doubled the operational expenses. So we need to think about it. And now we will see the results. The net balance in 2023 was positive, but in 2024 was already the same amount but negative. Something to alarm. Nevertheless, for the special emergencies, we saw that the amount of money invested was reduced from one year to the other, giving us the idea that if the emergency interventions has been reduced, it is because the preventive maintenance has increased, and it's not the case. So that's why we think that maybe it's an indicator that the information is not accurate. So maybe it's something to be revised regarding that. Nevertheless, we see that the KPI have improved a lot, and they are inside the bracket for the region. The benchmark for the region, Sub-Saharan Africa, are inside this bracket. Now this is the conclusion we did. We were talking before about 42% of commercial losses. So a basic arithmetic we estimated if we reduce by 15% the commercial losses. So we are going from 45 to 30%. There are still a lot of losses, but reducing it 15%. The expenses keep the same, but the results are positive again. So only by reducing the commercial losses, which can be obtained by enforcing the policy of the metering collection, installation of smart meters, etc. So this is something, this is a quick conclusion of this fast analysis. I think this is something to be taken into account by the management of LEC. In line with that, the information we got was a little bit not classified by categories or regions. So we are here suggesting categories for considering the operational expenses and maintenance to be included in the centralized ERP, to have all the information ready for analysis. We highlighted in green the one we consider need to be fostered. In red, what we need to reduce. Corrective operational maintenance, for example, emergency operations are expected to be reduced or even maintain their limits acceptable threshold. So there are 10 categories which should be included in the manual or in the procedures to be categorized. The operation of the utility has been possible because the government is injecting money. So we saw before a deficit of 9 million, but the network, the utility continues operating because the money is coming from the government. So there's something also to be considered, that for guaranteeing a sustainable growth of the network and of the country, it should be improved, this situation. Again, that passes through the increase the collection efficiency, reduce the thefts, implementing the smart meters, always controlled and guided by the existing standard we are proposing, and move from reactive to preventive maintenance approach. Okay, we already discussed about that. Those are the KPIs through the last 3 years. That's quite good, but there is room for improvement. We already discussed regarding EPA and the permits and how can they be included in the overall monitoring management plans for mitigation of emergencies. Okay, Luis also addressed this question before regarding vegetation controls. This is part of the management. The implementation of markers are diverters for the birds, and not only for the birds. It's also a risk and safety matter, because birds, depending on the span of the wings, they can impact even short circuit phases in the high voltage network or medium voltage network, and it creates a fault. Also regarding management of the environmental questions, we have the use of wooden poles treated with the contaminant materials like aerosols that should be limited and also be regulated by the existing standards. On the other side, there is a weak waste management enforcement. Sometimes when we are talking about right-of-way, for example, the restricted action plan can be improved because sometimes there are conflicts with the local population. And also the incomplete assessment, environmental assessment we talked before, can be improved. Okay, as part of the recommendations, we already, this is a must to do a full audit on the non-technical losses, because another aspect we have not mentioned here is how, for example, the lighting, the street lighting is measured, because maybe part of the losses we are considering losses are real use of the energy in lighting, street lighting. So if there are no meters there, maybe this is estimated or using some reference or whatever, which is not accurate at all. So this is one of the points we consider in first place to revise this 42% of non-technical losses. Okay, we already addressed this issue as well, condition-based maintenance instead of preventive, corrective. And also do it by differentiated by feeders and by regions. So the feeders where more outages are identified should be given the priority for the maintenance, and of course detecting what are the root cause for those outages. That means that even where this is one of the dangers of considering the ACIDI and ASIFI instead of SAIDI and SAIFI, because we will lose the focal point where the outages are there, and we will move for a more global analysis of the situation without less possibility of attacking the root causes. So I think both indices should be used, not only the energy production generation driven, but also the customer impacts ones. Also, regarding the treatment vegetation, we are suggesting to classify the species, vegetal species, in the region by their growth speed. All the species are not growing the same speed, so the maintenance plan should be adapted to each and every species for trimming every 2 months or every 6 months or once a year in order to reduce operational costs as well. Okay, finally, we already talked about EPA LEC procedures. Digital repository is in line with our computer management system, Unified, which facilitates as well obtaining the information, the data in real time and in a consolidated way. Okay, now we're moving to standard recommendations for design methodology. As it has been said before, several projects have been developed with different standards coming from different donors, and there is no heterogeneity in the standard and methodology system. So we identified in this task the methodologies which requires standardization or homogenization. For example, for route selection, circuit loading, and design practices. We have found in the route selection several inconsistencies or not optimal routes in different zones, in different areas. So it should be tried to obtain the several proposals for designing a route and discuss the pros and cons and select the best option from the technical and commercial point of view. We had, for example, I remember next to the ministerial complex, there is a turn around the complex. Instead of going straight forward, or even change the route slightly to minimize even the implementation cost, because in that case they need to include more anchor towers, which foundations are much more expensive, instead of trying to use suspension towers, which are enough for the implementation of the towers. Regarding the N-1 redundancies we were talking about also need to be considered. reduction of technical losses, compliance with the power quality parameters. Again, this is directly related to the voltage drops and the frequency maintenance. We are proposing the integration of the best practices to be unified and adopted by LEC. For doing that, we have consulted all the available stakeholders in the country. We had held meetings separated with them or even together to get their feedback to be included in our analysis recommendations. Well, it already has been explained as well regarding several substations which has only one transformer, leading to the risk of outages, because if these transformers get out of service, obviously the substation is not working anymore until the problem is sorted out. So the recommendation is just to use at least dual transformer per station to replace in case there are some within not good station because of the repeated overloading during years. It should be considered repairing or even doubling it. This is quite critical when we are talking about doubling the needs for 2030. The existing network will not be able to continue. Okay. Well, all of this information we have been talking about involves also directly or indirectly the reinforcement capacity for the teams on the ground and technical teams. And very important here, the protection philosophy. We were talking about many items, but protection is one of the main, because it allows to limit the impact of any outage and coordinate between the substations the load distribution. Andres also addressed this matter before. Thermography used to detect hot points and the potential loss of energy. The SCADA implementation, well, the 20-year plan for growing the network, considering always adapted to the standards, so existing standards. We also address the feeder level detection of the situation of the issues to be sorted out directly. One of the main considerations that need to be taken into account are regarding the standardize the towers regarding the material used, in this case the steel grade, and in the case of Liberia, very important to consider the anti-rusting capacity, stainless steel, to be able to support the high temperatures and humidity. Define the type of towers for suspension, dead end, etc. For conductor capacity, just to consider the thermal limit of the conductors as well as the transformers. And regarding the transmission, the protection, to structure it in the two layers, substation control and remote access terminal, and bay level. So that this way the faults can be isolated without impacting too much in the service. Okay, so as I mentioned before, there are many multifunction relays installed, many not, but at least some of them, which functions can be implemented and they have not been. So we here enumerate several of them, which we consider important to be implemented to improve the protection and reliability of the network. Finally, the configuration of the substations, bus bars, we also suggest to move to a more versatile configuration, including the ring bus, which is recommended when you have maybe 4 or 5 different lines in order to allow a continuous operation even in the case of faults. Same can be said for the brick and a half configuration, in which we have 2 bus buses, two bus bars, and 3 breakers sharing them. That's why 1.5. And finally, the double breaker configuration, which is more solid configuration, which allow even maintenance while the service continue in place. Okay, this is what I explained before, exactly. Now the methodologies, we need to consider the aspects for maintaining the redundancy in order to guarantee that when we have an outage of one or more elements, the network continue to be stable. We here mention, for example, not overloading the transformer above even the cable, the conductors above 70%, and even when the adjacent elements need to absorb the energy from an outage element, not overpass the 85%. This should be considered during the planning. Okay, we already talked about the actions, concrete actions at transformers, lines, and institutionalize. This is very important as well, to do the N-1 studies regularly, maybe once a year or after major upgrades. Well, long-term planning is related directly with that. Medium-term plan, systematic collection of demand data at the feeder level. This will allow to dimension the extension of the grid in an ordered manner. Yes, we have here some examples of thermal overloadings we have observed and need to be reduced or controlled. Yes, again, we have already talked about thermographic analysis, automation SCADA, and protection philosophy. So I think we are starting distribution. So we can continue. Maybe we can stop for doing some questions, if any. Thank you.
Good morning, everyone. My name is Aaron Meni. I'm an electrical engineer for Enrica International, based in Liberia. Been supporting the project from the data collection stage to the analysis up to now. So here I will be walking you through some areas that we have identified for improvement in the distribution network, as well as discussing the enhanced standards for components and materials recommended for the distribution plans. Then finally, we will go through sections on design methodologies, equipment pools, and land materials. So, to continue with areas of improvement for the network specific to distribution, we are recommending a long-term planning process, particularly a 20-year planning process for infrastructure investment in the distribution network, considering low costs, low effective costs and designs. In addition to that, we are also recommending a medium-term planning that requires systematic data collection at the field level. So one thing we did observe during our data collection visits to the substations was that the substation operators are currently recording operation data manually on paper, despite the presence of all the advanced logging devices that are currently present in the substations. So this is very important for planning. It's very important for things like demand forecasting, because you have reliable data as compared to the 1 hour interval reading that is manually recorded on paper, which is very, very error prone. So that's one of the key areas of improvement we have identified. For reliability, I also recommending we have identified areas that needs to be improved, particularly the corridors of the network where when you remove one component, the N-1 scenario doesn't really stay. Remove one component, it's really impacts reliability seriously. So it would be a good idea to have the constant inspection of this N-1 contingency and assessment. We are saying that should be done on at least an annual basis. For maintenance, so things like thermographic analysis is extremely important for the network. There are sometimes you travel across the LEC network at night, you visibly see hotspots on transformers. You see icons happening at certain transformer terminals. So those are places that really require improvement. It has been mentioned several times this implementation of SCADA. We understand that LEC is in the process of doing that, but expediting that will be extremely important for to eliminate some of the issues that are currently on the network. Protection, so currently the protection scheme, things like overcurrent and ground fault scheme is needed, done conventionally. So we think that it would be a good idea to take advantage of these advanced devices that are currently installed in the substations, having them properly configured for long distance detection of faults. So now we will talk about the enhanced standards for the components and materials. So our key recommendation when it comes to post selection, as it has been mentioned so many times here, there are different types of materials all across the LEC network. You find concrete poles in certain places. Just next to that concrete poles, you find steel poles. Just next to that, you find wood poles. So, key recommendation is that in the urban and peri-urban areas, we are recommending to use the pre-stressed concrete poles where necessary. And the various thinners that are required for these concrete poles are also specified in the various reports that we have provided, as well as in the manual that we have developed. For rural areas, the recommendation is to utilize wood poles where necessary, while also taking into consideration the risks of wildfires. So whenever is has been observed or assessed to have risks of wildfires, other types of poles like concrete can be used in those areas. Our manual provided very comprehensive guides on the design of these of the poles. So let's talk about construction units. One thing that was also noticed from the information shared by LEC is that the different construction units are not standardized, and there are no codes to specify which unit, each unit, I mean. On the international standards, for each voltage level, there are codes associated with various units. So our recommendation is to adopt those standards. So for instance, for a 33 kV distribution network, the standard is to use these type of letters where you see ZC1, and the Z represents the voltage level. Z means 33 kV, and then the C1 or whatever carrier that comes out that represents the type of structure you are dealing with. In this case, the C1 represents a tangent structure. For 22 kV, the standard is to use VC1, VC2, so the same V here represents the voltage level, and the C2 represents the structure. So you see in all the drawings that we are submitting to LEC, it has it follows this standard. So for another thing that is important is the different construction units as it relates to different line angles. So for instance, for intermediate poles used for smaller line angles, small medium-sized line angles between 4 to 20 degrees. Recommendation is that you should have 2 post insulators. We identified during our inspections that there are some very large angles in the network where there's only one insulator being used. You have a 15 degree angle in one insulator, you clearly see the insulators leaning. So our recommendation is to avoid that. LEC needs to transition to using 2 insulators and 2 cross-arms for this type of line angles. So the drawing clearly stated all of those things, and some of the comments you see here, these are things that we've noticed in the existing LEC design. Another key point is the dead-end structures. Dead-end structures, as you may know, they are the ones that basically will hold the weight of the entire section of the line till you get to the next dead end. And it was also observed that the use of single cross arms. So we are saying that to avoid issues of failure in the future, we are recommending to use the double cross arms at the dead end. It provides a much more robust system to avoid failure. And we provide clear instructions on how the cross arms should be installed. So another thing is, there are other standards that are very common in line construction that is not being used by LEC. There's a structure we call ZC3 and ZC4. These are for very large angles, between 60 to 90 degree angles. And these are not being used by LEC at all. So, and we know that it's going to require additional materials which LEC may not have available in their inventory. So what we did was we did an assessment and then came up with a solution for such structures that will utilize materials that are available at LEC, as you can see from this diagram here. So this is clearly specified in the manual that we are providing to LEC. So let's talk about the conductors. So the LEC network is mainly made of ABC conductors, and I recommend that it stays that way, avoiding the use of bare conductors or these vertical construction of LV lines. So here we have provided good guidelines on the methods to follow when designing and extending the line. So for example, let's say you have the community and you need to extend the medium voltage line to that community. There's the demand forecast has to be performed. And then the medium term, year 5 analysis, and then the long term, year 20 analysis. And this includes things like doing projections on the number of structures. So you start with the current number of structures that are available in the area, and then considering the growth rate of the community, and project the 5-year and 20-year term, and that gives you a complete idea as to how the law is going to evolve over time for that period. Transformer sizing and placement. One thing that is very common in the LEC network, it was not common initially, but it's very common nowadays, is the use of very large transformers, which is logical. I can understand why they are using large transformers, because of population density in some of those areas and the demand in some communities. But the challenge that comes with that is the tendency to continually extend the length of the low voltage network without taking into consideration voltage drop along the line. So we are recommending using smaller size transformers to minimize the length of the LV lines where possible. Another key recommendation is using GIS-based clustering for analysis. We understand that LEC has a very good GIS database, and the study that was done by us, we also passed over the geospatial data that was collected during the project over the LEC. But for when it comes to the placing of the transformer, this is using GIS-based clustering is extremely key. That helps to limit the length of the line. The transformer loading, I think it's obvious that this is one of the places where the most improvement will be needed in the distribution network. There are communities that have overloaded transformers blowing off. The cost of the single transformer is very, very high. Just paying attention to reducing the loading on the transformer by save LEC a lot in the future. So our recommendation is to keep the loads on the transformer within 70 to 80% of the transformer capacity, not exceeding 85% in the worst case. And how can this be done? It would be good for LEC to implement transformer monitoring system. That's the only way you can actively monitor the load of the transformer. We understand that right now these monitoring systems are not in place, but the team is already doing annual inspection of people visiting customers to pick their house. So having some advanced devices that allows for monitoring. Single phase versus three phase. The LEC network at current have fewer single phase lines. I think it's aware a lot of them already have in place, but we are recommending for rural education, it might be good to start with single phase construction where possible, and only implement three phase when experiencing challenge. This is PFD cost. Here configuration is another key area. We have been observed that most of the networks, especially the ones that are outside of central Monrovia, are largely radio that is long single lines or continuous in the community. And something happens to that line, there is no way to move the single. So the recommendation is to have this good configuration implemented in most part of the network. There are in the center of Monrovia several places where this exists, but as you travel to the edge of the network, this is where for conductors on the video voltage line, obviously will be our recommendation, both video voltage and low voltage, our recommendation is aluminum, and for obvious reasons it's much cheaper than the copper where it's really necessary for critical applications. So there are this distributed energy resource that seems to be in the workings that might be installed, that are being brought into applications on the LEC network is very critical. We want LEC to establish a protocol that will work with independent power providers for technology disclosures and pre-connections and technical reviews. And these variable renewable power plants should all be connected directly to the SCADA systems that are being implemented for real-time monitoring. The other issue that arises with these VRPP is the issue of harmonic limits. Our recommendation is that the total harmonic limit of any system that is being connected to 66 kV network should not exceed 1.5%. So for design, we understand this is already being done between LEC and the EPA. For right-of-way clearing, this is extremely key. Our visit to Clay substation showed a lot of places in the network where the right-of-way is not being properly maintained, and this basically leads to issue of ground faults along the network. So it's key to have a dedicated team that constantly monitors vegetations along the line and act proactively on it. Things like compensations for, so for example, you have projects that may affect like certain people, what we call PAPs. So there might be, it could be designing a project that goes in a community that that will affect people that live in that community. Compensation may be provided by the government to cover such issues. So commissioning, this is very key. It's a critical component of projects, and this is when you really establish that things that are specified within the scope of the project are being delivered. So we have provided extensive recommendations on this, and things like pre-commissioning, considering as-built documentation is also very key. Some of the projects that we have evaluated for LEC, we could not basically get any records on them because of the lack of these documents. So it's a key recommendation for us as well. Testing and verification is also very key to this. Things like insulation testing and land pressure testing. Insulation testing basically we identify things like land leakage and land pressure testing. F-resistant testings are all recommended, and we provided the standards to be followed during the commissioning process. And one of the most important assets in the network is the transformer. So doing a key commissioning process for this transformer is extremely important. Things like verifying characteristics like behavior ratings, manufacturer details, confirming tap switch settings, setting ground connections, very key, and also conducting a transformer turn ratio test is extremely important as well. All right, thank you. I will take questions if there are any.
Good morning, Joseph D. Stewart from the SCADA and Telecommunication section of TNT. It's not a question actually, since we talking about standardizing the system. I hope or I recommend that we factor in our telecommunication components or materials. So I had a task to interconnect the 13 substation by fiber, and that is done through the OPGW, and it's an integral part of the transmission line. So if we must standardize our system, let's factor in our ODF. The ODF at our various substations, there's no standard. So from Bushra to Mankofe, from Mankofe to Pittsfield, we are using the E2000 connector, different. From Pittsfield to Shefflin to RRE, we are using SC connector, different. Bushra, Virginia to Clay, we are using FC, different. Covertown, Capital to Pittsfield, we are using ST connector, different. So if we must standardize, please factor in telecommunication. Thank you very much.
Thank you. That recommendation is noted.
Okay. Once again, I'm Frank Noel from the Commission and Distribution Department of LEC. Quite frankly, 10 thank you for your presentation. Well, then we are talking about standardizing our material. So I will speak specifically regarding the issue of pool. In one session, we talked about recommended concrete pool, which may be healthy for our society and even our citizenry. And then you can go around the moving pool, children will have some hazard, meaning that it has to do with some environmental effects. But again, I saw in one of your presentation in the rural, preferring us to still use moving pool, which will be hazardous. Because in some way, we even had an EPA agent to patrol the what's happening there. And the moving pool should have duration. And they set on the moving pool. So you don't think it will be necessary to just standardize our system and then use the pumping pool instead of recommending the moving pool within the water. Thank you.
That's a very good point. We did that according to consideration. I would like to mention one thing that why the concrete pool is very attractive for most constructions in the rural areas where you have lines stretching across long distance. It can be really challenging for transportation. So that's why it is highly recommended, even in the areas quality, to use wooden poles for rural areas because lightweight. It is very easy to transport across long distance. Regarding treatments, we do have an extensive writing in the reports and in the manual on the type of treatments that you can use for the poles that will have minimum impact on the environment.
Okay. Thank you, Aaron, for the presentation. I just have a few questions. My first question or concern focuses on the specification of materials. We're talking about having a standardized materials in our network. And I speak from experience. Are we also considering the specification of the different materials we are recommending? I say for an example, let's take pool. If you look into the LEC network, you will see different kinds of wood pools, different diameters. If we just deal with maybe saying concrete pools for rural environment and wood pools for urban environment, it's not going to solve the problem at the end of the day. Because when this document is completely developed, it's going to be left with the different engineers now to use their interpretation as to the different diameters of the pool. So we have to have a complete specification for each of the equipment that we want to introduce into the network. The next thing is, for example, transformers. One thing that I've experienced in the field is there is no specific specification for transformers in coastal areas. If you did a survey along the coast, you'll realize that both of the transformers there are already rusting with the materials or equipment that are installed in it. Now, with the different manufacturers we have or we deal with, they give you what you want. So if you give them a specification for places that are not close or that are not coastal related, they are going to give you transformers that will survive in such environment. But again, you are forgetting that you have coastal environment. you're going to take those transformers and send them to the coastal environment. And once you do, after a few months, those transformers begin to rust. So that's something that we have to look at. Let's have a complete specification. Another thing that I want us to look at, I don't know whether you capturing that, is to have a complete POM for poles, transformers, and any other thing that we cross down, any other thing that we want to use. The reason for that is, if we don't have these different POM for the materials or these equipment, the engineers or the technicians will now begin to decide what material to use. It means we are not solving the problem. We will have the document will speak to it, but at the end of the day, you will see different things there. I also want us to handle this like a project. When I say like a project, I mean the execution phase. When this document is being developed, that execution, I want us to treat it like a project. What am I trying to say? Can we have M&E department or unit in LEC that will monitor procurement of the different materials and also monitor the installation of the different materials in the field? I feel that when we introduce these measures, LEC or even the standard that we try to develop today will force LEC to have a use. One of the major importance of having M&E department or unit at LEC to monitor these things is during procurement. If you don't have these engineers who have idea on these electrical equipment, perhaps you just take somebody who did procurement say, we need transformer, and they use their own description. You know what I mean? You will not be getting what you want. At the end of the day, when the installation is being done, there is nobody to monitor as to whether it was done rightly, it is not done rightly. So we need to put in place these measures to ensure that what we are here for is achieved. Because this is something that the institution is lacking. Thank you.
That's a very good. Let me just address a few things that we did and then move to the next. So the first point on timing or post, this is something that we covered very well in tax 6 report as well as tax 8 report. So the rate because of that you can have in the field, right? In the depends entirely on. It contributes to the strength of the pool. So we do have several tables where that allows you to pick the proper pool material versus diameter versus bending moment of the pool. So those are well covered in there. The comments on transformer for coastal areas is well taken. We do have recommendations on what type of transformers to be used, especially along the coastal areas. We will take recommendations seriously and also evaluate that just to make sure that it covers everything. Every drawing we provide for the person different construction units, you have a table here that indicates the materials that we use for each part of that construction. So for instance, for each material you have a number behind that, and then there is a note number on the floor that tells you that this is where the material goes. So this is well covered as well. I think, and according to this. So Thursday we'll be discussing the drones, the pilot design that we are proposing. We will really like the person from NRC to be there to go through what we are proposing, to analyze how it fits with what we are proposing to LEC.
My name is Sandra Chino from Labrostellos Aquarium. So to follow up with what my colleague from LERC was saying, looking at procuring of these equipment, we should also consider conformity assessment with the standard organization we will all conclude. So, for example, looking at the specification for transformer along the coastal area, how can we ensure that these specifications meet compliance? So when we do the conformity assessment, we either issue certificate of compliance or certificate of quality before procurement. So I think we can add that section into the procurement process, conformity assessment. That we can do.
Well, thank you. Okay, we'll take one more comment.
Okay, thank you very much for the presentation so far. My name is Shaja Bakwa, Principal Engineer at LEC. Okay, you know, as a planner, you know, we've been facing issues, especially when the industrialization coming up with a lot of, you know, roads, especially in the urban areas. You know, we spoke about right-of-way and construction. You know, we tend to have difficulty sometimes trying to connect some industrial customers because there's no route. So, is there any consideration for you know, maybe double circuit line support to help us with that? Because currently we have that kind of issue, you know, because there's a divide. We have to provide access to, you know, partners and also to the customers. So maybe that's constructive unit for double circuits might be really helpful in consider that. Also, you know, setting areas requires no overhead lines. So I don't know whether there's any consideration for underground networks. I don't see anything of that sort. So it's on.
Great. Yeah, thank you very much, Joshua. So double target construction, yes, that's definitely something that we're going to take into consideration. And then for the underground construction, yes, we will provide information to LEC on that. Thank you. All right, now let me pass over to Andreas to continue the next presentation. Thank you.
So the Aaron there doing his presentation. Let's now take a technical break. I'll be right back.